Namaskar. Good evening, everyone. So once again, we are again here with all new chapter from grade 11 because it was demanded by the students that I should make uh, on chapters related with grade 11. So today we are beginning with grade 11th chapter number 8, composition and structure of the atmosphere. So I will be just playing the PowerPoint presentation and let's begin the chapter. Hope you will enjoy it. First of all, I would like to request you that you have to subscribe my channel, Swamev Educational Foundation, and like and hit the bell icon. Thank you so much. So let's begin chapter number 8. Chapter 8, composition and structure of the atmosphere. So, dear students, if you are able to see here, so what are you able to see here? There are several things which you are able to see. For example, here you are able to see troposphere, you see ozone layer, then stratosphere, then mesosphere, then thermosphere, you are able to see exosphere or exobase, outer atmosphere, the Kerman line. Okay, so we will discuss all these layers today in this chapter. And I assure you that you are going to like this. Uh, so let's begin with the chapter. Before I begin, let me ask the question. Uh, what is atmosphere actually? If you are asked that what is atmosphere, how you are going to define it? So if I have to say that what is atmosphere, so basically it is the air and mixture of composition of different types of gases, dust particle, water vapor, and different layers of the earth which envelop around it and create a blanket like cover to protect earth. So that is called atmosphere. So basically you need to understand atmosphere envelopes the earth. It is life-giving gases and 99% of the mass of the atmosphere is only confined to the height of 32 kilometer. That means beyond 32 kilometer it is rarefied atmosphere. Now, what is air? Air is colorless and odorless. Neither you can just have the smell, neither you can see the color. So it can only be felt, and felt in the sense that wind. So in next chapters we will come to know how does wind blow, what is wind, all these things we will come to know later on. But today we are just going to do about the atmosphere. So see the composition of the atmosphere, if you see, so you will be able to see here, or you will be able to understand that there are several gases in the atmosphere. But if you are able to see the share of different gases, so you will be surprised to know that 78.08% it is mainly only what we have, the nitrogen gas. See here, whereas oxygen accounts for almost 21%, that is 20.95%. Then the next biggest gas which is found in the atmosphere, it is argon. See, 0.93%. And if we talk about carbon dioxide, see here, 0.03% only. So that means carbon dioxide is very less present in the atmosphere. So when we talk about the atmosphere, so atmosphere, what we need to say? We need to say that atmosphere is mixture of gases, water vapor, and dust particles. So proportion of gases changes in the higher layer of the atmosphere, and oxygen negligible at the height of 120 kilometers. Carbon dioxide and water vapor are found only 90 kilometers from the surface of the earth. After that, you will not neither find carbon dioxide nor the water vapor up above 90 kilometers from the surface of the earth, or you can say from the sea level as we move up in the atmosphere. So if you see, so these are the different composition of the gases, and let us come to the next one. So composition of gases, the first part of composition of atmosphere, the first part we have done, that is gases. Now after gases, see here, the gases create a greenhouse effect. Clear. Let me clear. Okay. So see here, gases, the greenhouse effect. If you remember, if you must have seen what is greenhouse effect. If you remember that at your if you are driving a car, and if you have parked it in the means open area where sunlight is coming, and your glasses or windows of the cars are just shut or closed, so what will happen after 10, 20, 30 minutes? When you come back, you will find out that the inside of the car is hotter than the outside atmosphere. Why does this happen? Because glasses act as a trapping. They trap the energy because the sun waves come in short wave. So short wavelength. So they are able to penetrate. But when the car tries to emit back whatever it has received from the sunlight, so what happens? It is in long wave. So what happens? It is not able to go outside the atmosphere or outside the car, or it is not able to cross glass, and that's why glasses are used in cars and several other places to make it a dome-like structure you will be seeing in Canada in different buildings. So to create a greenhouse effect. So as you know that carbon dioxide is meteorologically important. Now, why it is important? Because it causes greenhouse effect and maintains the balance on the Earth's surface and make the environment living like conditions. So it is transparent to incoming solar radiation. So incoming solar radiation, which are in short wavelength, they will enter in the atmosphere, whereas the outgoing terrestrial radiation, which is in long wave, will not be able to go back. So Earth, it is not able to cross. So what happens? It is largely responsible for the greenhouse effect on the surface of the Earth. Now there is another important gas which is found in the atmosphere, and without which probably we will not be able to survive. So that gas we will see, that is ozone, which we are going to talk about. So greenhouse effect and global warming, as you know, volume is increasing. That means carbon dioxide is increasing. We are consuming fossil fuels and other CFCs, chlorofluorocarbons, which are being created. So these are resulting in the increase in the temperature. And the ozone layer, which is the important component which protects us from the UV rays coming from the sun, it is being depleted because of CFCs, chlorofluorocarbons. Now, what is happening? If you know that ozone layer is an important component of the atmosphere between 10 to 50 kilometers above Earth surface. Now, it acts as a filter and absorbs the ultraviolet rays coming from the sun and prevents them from reaching the surface of the Earth. And that's why ozone layer becomes important. Now, let me tell you that several times the teachers ask these questions, that what is the importance of ozone layer? Or they may ask question like, what will happen if there is no ozone layer on the surface of the Earth? So you have to give your answer and you have to just answer it accordingly. Now, so next thing which atmosphere composes is water vapor. Now, water vapor is really important because it is also a variable gas in the atmosphere which decreases with the altitude. As we move up in the atmosphere, it will decrease. It decreases from the equator towards the pole. Yes, that is also true because poles are colder areas, whereas equator is warmer. So what will happen wherever the warmer air is more? So what will happen? The more evaporation will take place, and because of which the moisture content in the atmosphere will increase. Whereas in the colder areas, because it is cold, so what we call evaporation process will not occur, which will not lead to the addition of the more water in the atmosphere and increase in humidity. So now, warm plus hot tropics account for 4% of air by volume. So warm areas and hot tropics. Tropics means tropical areas between 23.5 degree north and 23.5 degree south. That means Tropic of Cancer and Tropic of Capricorn, in between the areas which are lying there. So whereas if you talk about the dry and cold area, deserts, polar regions, they have less than 1% of the volume of the water vapor. So water vapor absorbs the parts of the insolation from the sun and they preserve earth when it radiates heat. So that means in a way, water vapor acts or maintains the stability and instability in the air. So water vapor also contributes to the stability and instability in the air. Now, after this, water vapor, let us come to the next part. Next part is dust particle. Now, this is really important. You have to understand how dust particle act. So, atmosphere has a sufficient capacity to keep small solid particles which may originate from different sources and include sea salts, fine salt, smoke shoots, ash, pollen, dust, and disintegrated particles of meteors. So you see what they may have, the small solid particles in the atmosphere originating from different sources. And what are those different sources? Sea salt, fine soil, smoke shoot, ashes, then pollen, dust, and disintegrated particles of the meteors. Because when meteors enter, they just burn in the atmosphere, and that is also whatever they are. So their ashes is also mixed with the atmosphere. Now, what happened? These dust particles are generally concentrated in the lower layer of the atmosphere. Yet, convectional air currents may transport them to great heights. So now, convectional currents, you must have read about it, you must have heard about it. What are convectional currents? How they are formed? If you remember, if there is a warmer, so what will happen? Warm air rises and it will create a vertical uplift of the air which will go in the atmosphere at a greater height. So, and cold air subsides. So, a convection current is formed. So, such type of uplifting of the means dust particle, gases, and water, okay, because of the convection current. So, this is known as movement convectional air currents. So now the higher concentration of dust particle is found in subtropical and temperate regions. So dust particles, you can say that subtropical areas or temperate regions have higher concentration. And why it is so? Because due to dry winds in comparison to equatorial and polar regions. So in equatorial regions and polar regions, we have comparatively more moisture laden winds. So they are not, they subside or they just make these dust particles to settle down. Whereas in temperate regions and subtropical regions, winds are dry, and that's why, if you remember, deserts are mostly located in subtropical, or you can say temperate regions and subtropical area. So dust and salt particles act as hygroscopic nuclei. Now, what is hygroscopic nuclei? Because they make all these water vapor condenses around these hygroscopic nuclei to form into water droplets. And finally, after the condensation, it comes down as rain. And that's why this is really important. Now, after dust particle, let me clear it. Okay. So this was about the composition of the atmosphere. If you are asked that what is the composition of the atmosphere, so basically, first of all, you have to explain about composition of different gases. Now, when you are describing different gases, so what composes, like the nitrogen, what is the percentage of nitrogen, what is the percentage of oxygen, then argon, and you can say carbon dioxide. Now, ozone is another important layer which need to be greenhouse effect also can be explained here. Then we are coming to the water vapor. Water vapor, like why it is important, how it just creates, and why its concentration is found in different parts of earth, or as we its concentration is higher in the lower latitudes in comparison to higher latitude. And why does this happen? So this need to be explained. Then dust particles, what is their importance in the atmosphere, how they help in condensation process, so this need to be explained. So this is a complete 3 or maybe 5 marker question. Then coming to the next one, that is the structure of the atmosphere. Now this is important. This is a 5 marker question if we talk about. So hygroscopic nuclei we have done, and we are dust and salt particles, hygroscopic nuclei around which water vapor condenses. This I have explained already. So now, structure of the atmosphere. Now let us see what are you able to see here and why it is like this. So let's see what happens. Let me first opt for annotation. Okay. Now, perfect. So if you see the structure of the atmosphere, it consists of different layers. See the lowest layer here, it is troposphere. Then you find stratosphere, then mesosphere, then thermosphere, and then exosphere. So these are the different layers which you are able to see here. Now remember, as I have already told you, that uh, moisture, or you can say humidity, or the content of the water will decrease as you move up in the atmosphere. So if you are near the earth's surface, there will be higher or dense atmosphere. I have told in the beginning only that beyond 32 kilometers in up in the atmosphere, only 1% atmosphere exists. So decrease with increasing altitude, yes, definitely. As we move up in the mountains, you will find that air is decreasing. If you remember what happens when you are higher altitudes in Himalayas, so you are advised to just use mask, oxygen mask. Why? Because your blood air pressure is really low. So what will happen? Blood vessels may just break or rupture. That's why, if you remember, you were asked in grade 7th or 8th in science that why pulses uh, means these are not cooked very easily in mountainous areas. Why was so? It is because of the atmospheric pressure which is low in the mountains. So you need to understand that as we move up in the atmosphere, the what do you call air pressure or atmospheric pressure decreases, and its density also decreases. Now temperature, if we talk about the temperature, as we move up in the atmosphere, the temperature will also decrease. And now, how it will decrease, how much it will decrease? So let me tell you, there is one normal lapse rate which we talk about. That means approximately if you move 165 meter up in the mountains, so what will happen? 1 degree Celsius temperature will decrease, which is known as normal lapse rate. So normal lapse rate is 1 degree Celsius temperature will decrease every 165 meter up in the altitude. So that is. Now, if I have to say that the column of the atmosphere is divided into 5 different layers depending upon the temperature conditions. They are troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Now let us discuss one by one all these layers. So yes, here it is. So layer of the atmosphere, the first one is troposphere. Now this is the lowermost layer of the atmosphere, and its average height is 13 kilometer. That means if we talk about at poles, the height of this troposphere is only 8 kilometer, whereas at equator it is more than 18 kilometers. That's why there is a difference. So that's why we have taken average. So average height is 13 kilometer for our convenience only. Now, so if we talk about thickness of the atmosphere, it is greatest at the equator. Why? Because heat is transported to greater heights by strong convectional currents. Just in the previous two, three slides, we have discussed how the air moves because of the convectional currents, and this leads to rising the taking up even gas, dust particles, and even moisture also. So these are taken up in the transported up in the atmosphere. This layer consists dust particle and water vapor. So all, remember, this is one of the most important thing which you have to just remember, that all the changes in climate and weather takes place in this layer only. The temperature in this layer decreases at the rate of 1 degree Celsius for every 165 meter of height. This we have read. That means normal lapse rate. And another important thing you have to remember, that this is the most important layer for all biological activities. So that's why troposphere is one of the most important layer of the atmosphere. Now, if you see, most of the climatic phenomena also takes place here only. Let us come. So climate and weather takes place here only. Temperature, that's we have done, and important biological activities, that's also we have done. Now let us proceed further. Next layer is tropopause. Remember, why pause? Because there is a transition zone. There is not a like a line and you will just cross this line and you will enter somewhere else. For example, let me show you here. It's not like this layer, suddenly this was a troposphere and you have crossed here and it became which layer? Stratosphere. No. So there is a transition zone. So say 1 kilometer or 2 kilometer or say 3 kilometer, there is a transition zone where both stratosphere and troposphere merge with each other, which came to be known as tropopause. Remember, these pauses have been named after the lower side of the layer, not the upper side of the layer. So that's why it is, because lower layer is troposphere, that's why it is known as tropopause. Now here troposphere stops. After troposphere stops, we just go up in the atmosphere. Now, the zone separating troposphere from stratosphere is known as stratopause. tropopause. The air temperature at the uh, tropopause is about minus 80 degrees Celsius. So you need to understand that how cold it is here. So as we move up in the atmosphere, temperature decreases. We have read about it. So that means when we reach tropopause, the temperature has already become down to 80 degrees Celsius. Now over the equator, and minus 45 degrees Celsius over the poles. So poles, on poles we have more less temperature decrease. Now temperature uh, here is nearly constant, and here hence it is called tropopause. So in tropopause, temperature is constant. Before tropopause, in troposphere, temperature has decreased to minus 80 degrees Celsius. Now after this, once again, what happens? The stratosphere is found above the tropopause and extends up to a height of 50 kilometer. So let me just clear this drawing here and move further. So that means its height, the stratosphere, 50 kilometer, it reaches till 50 kilometer, and it is found above the tropopause. It contains one of the most important layer, which is known as ozone layer. Now, why it is important? Because this layer absorbs ultraviolet radiation and shields light on the earth from intense harmful form of energy, which is also known as UV rays. So that's why stratosphere is really important. Now, as the name suggests, if I tell you, as the name suggests, stratosphere, so static conditions are there. So what will happen? This is a zone where most of the planes fly. So you have to remember that you will not have any what you call, like if you are traveling from plane, so they say that disturbance, turbulence is there. So turbulence are found in only troposphere, not stratosphere. Stratosphere, it is static, are no changes, something like that, and that's why these are the safest for the flying plane. Now let us come to the next layer after stratosphere. So after stratosphere, we come to the mesosphere. Now, mesosphere, before coming to mesosphere, let us come to the stratopause. Another important thing which I just wanted to tell you here, if you see here, let me. So see, if we see this line here, so temperature is increasing once again from tropopause. In troposphere, temperature was decreasing. In tropopause, it was static, and after that, it started increasing. Now, when it reaches a stratosphere, once again, it becomes static. Now, the stratopause is a layer between which separates mesosphere from stratosphere. So, it is a transition layer. Now, it lies above the stratosphere. It extends up to a height of 80 kilometer. So from 50 to 80 kilometer of altitude, you will find mesosphere. Now, in mesosphere, temperature starts decreasing with the increasing altitude. So that means if you see here, let me show you. Here, see this. What is happening? Temperature is decreasing. So it is reaching minus 90, or sometimes even reaching minus 100. So it reaches up to minus 100 degrees Celsius at the height of 80 kilometers. So that may be possible. So the upper limit of mesosphere is known as mesopause. And when we reach mesosphere at the top, so it becomes mesopause. If we talk about after mesosphere, there is another important layer which we must talk about. Let me first clear all the drawings. Okay. Ionosphere. This is really important, and you might be asked a question to specifically write a short note on ionosphere. Why it is important? So, ionosphere is located between 80 kilometer and 400 kilometer above the surface level. So, what happens in this layer? If you talk about, it contains electrically charged particles which are known as ions, and hence it is known as ionosphere. So this is a magnetosphere also. Why it is important? It is important because it contains electrically charged particles, and all the radio wave transmitted from the earth are reflected back to the earth. That's why it is important. That means whatever the communication we have, satellite communication or radio, television, internet, whatsoever we have, all these communications are possible only because we have ionosphere. Had ionosphere not been there, probably we were not able to create such types of devices through which we are able to communicate today. So radio waves transmitted from the earth are reflected back to the earth by this layer. So temperature here starts increasing with the height. So as we move up, we will be able to see here, see, temperature is moving up. So temperature starts increasing in this height. The uppermost layer of the atmosphere. So the uppermost layer of the atmosphere is exosphere actually. So this is the last layer which merges with the outer space. So it lies above thermosphere, or you can say ionosphere. And here, if you remember thermosphere, name thermosphere because temperature starts increasing. That's why its name is thermosphere. Clear? And as it merges, it lies above the thermosphere. Whatever contents are there, these are extremely rarefied in this layer, and it gradually merges with the outer space. So that is one of the most important thing we need to know. And this is the highest layer, but very little is known about it because whatever contents are there, these are very rarefied. And although all layers of the atmosphere must be exercising influence on us, geographers are mainly concerned with the first two layers of the atmosphere. And which are those first two layers? Troposphere and the stratosphere, because maximum things are occurring in these two layers for us, except ionosphere, which is one of the important because it reflects back the energy. No, sorry, the communication signals. So now, if we talk about elements of weather and climate, so the main elements of weather or atmosphere which are subject to change and which influence human life on the earth are temperature, pressure, winds, humidity, clouds, and precipitations. And we are going to discuss these elements in detail in the coming chapters when I will be dealing with them. So remember, students, this was the chapter. I hope you enjoyed this chapter, and I will wait for your feedback also so that I may be able to give more detailed summaries for other chapters also. And let me tell you once again that you have to subscribe Swamev Educational Foundation YouTube channel so that you can get more such videos, and comment there, like it, and hit on the bell icon so that whenever I upload any new video, you can get it. And as you know, Swamev Educational Foundation is a charitable organization which is working for educated and empowered Bharat, especially in the field of education, where it has started Shikshadan, and where it has also started another project, which is second project, which is known as uh, means female health and hygiene. So that is important, and it has started a membership drive. You can just visit its Facebook, Twitter, Instagram, and other LinkedIn IDs, and you will find every detail. Even it has uploaded the Google form where you can just, if you are interested, you can just sign in and become the member of this organization to spread this awareness. So I will say thank you so much for today, and I'll see you once again with new video in next section. Thank you so much.